Chapter 10, List Part 3, last video. Let's knock this out. Write a program that reads in numbers separated by a space in one line, and then displays only the distinct numbers, the numbers that appear. If they appear multiple times, we only want to show one number. So the example is always easiest where we start from, down here. It says enter 10 numbers separated by spaces. So we're going to read it all in one line. We're going to scan that entire thing using input, get that whole string. We're going to split it based off of spaces. Then we're going to use list comprehension like we showed previously and convert that new list of strings into a list of int values, of integers. So we're going to scan this entire list in, and when we're done, notice it says the distinct numbers are, and we show the distinct numbers. So as we always do, before we get to actual coding, problem solving phase, which I have right here on the same page. Hint, read all the numbers and store them into a list. We're going to do that. Then it says create a new list. Let's call it list 2, or maybe I'm going to call it distinct numbers. Add a number from list 1 to list 2 only if the number in list 1 is not already in list 2. And I have on the next page the solution, but let's go code it up live. Open up Thonny. So what we want to do first is read numbers and store them into a list. So let's call a main. Let's come up here, make a main function. And on line 1, we want to do what? We want to read numbers and save them into a list. So we could make input line equals using input. So this is going to be scan a line of input from the user. And now we want to split that. So we can do it in multiple steps. Check this out. And we want to enter 10 numbers. So I'll do this in 3 lines. Enter 10 numbers. Now we want to split that. I'll call this numbers as strings equals input line dot split. So we're splitting it based off of spaces. And now we're going to use list comprehension to convert that list of strings into a list of integers. And so this is going to be int of, I'll call it val, for val in numbers as strings. So let's just print numbers as strings. And then let's print numbers, because this is not part of really solving the logic of the problem. This is just making sure we remember how to read input like this. So enter 10 numbers, 1, 2, 3, 4, 5. I'm going to only enter 5 numbers. So notice how when I say print numbers as strings, we have a list of string values. Now each of those individual strings, we can see it has a character number 3, the character number 4, or the character 5. And I'm saying character because it's enclosed inside quotation marks. But it's really just the number 5, but it's as a string. So how do we convert it to an integer? Because you see the result here. Now we have a list of integers. We used list comprehension, which we've already covered in a previous video, although it was short. So that's why it's worth revisiting this. So here, what we do is we have this for loop, which loops over every single one of these 5 values, these string values inside this list. Individually, each one is going to be saved inside this variable val. So this string with the character 1 gets saved into val. Then this string 2 gets with the character, this string with the character 2 gets saved into val. And then this string with the 3 gets saved into val, and so on. And each time it saves one of those strings into the character val, it then casts that and converts it into an integer. Long story short, what we see when we print numbers is we have a list of integers, which is what we want, and now we're ready to solve the problem. So all of this is not solving the problem. This is just scanning the input in a smart way to get us ready to actually solve the problem. So here we have 3 lines of code. We can really do that in 1 line. Well, think about it. what is numbers as strings? Let's start from the bottom, this third line. Let's then look up to the second line, and we'll work upwards and then look at the first line. So here we have this third line of code here. What is numbers as strings? Well, it's right here, and it really equals this. That's an assignment. So instead of putting numbers as strings here, you know what I'm going to put there? I'm going to say input line dot split. What is input line? Input line is this variable, right? So it's just this variable right here stores that entire string of input. And you know what? Let me even first print even input line so we can see all of that. Print input line. So let's put, again, 5 numbers. 1, 2, 3, 4, 5. So here we have that string input line, right? This is a string of input. Now we have this list of strings, which is called numbers as strings, and then we have the list of integers right here. So again, what is numbers as strings? Well, it's really just the result of that input line after splitting it. So since this is an assignment, you know what? I can just take all of that and put it right here. I don't even need this line of code, right? So I've done that. And now when we look at this line, I say, well, what is input line dot split? Well, what is input line? Input line equals this thing. Because this right here results in, we're using the input function, which results in scanning a string of input from the user. So I can really just take this, all of this right here, since it's an assignment, I can take all of this, copy it, and wherever I see input line, I can just get rid of input line and I can do that. That's a long, super funky line, but it works. So I'm going to edit the comment here, scan a line of input from the user and save it into a list of integers. Nice. So now if I just print numbers, 1, 2, 3, 4, 5, there are my 5 numbers. So now that we're done, we can do something problem specific. What is problem specific? Create a new list. I said I'm going to call it distinct numbers. So create a new list called distinct numbers. And I'm going to make it empty. Oh my gosh. There we go. And add a number from list 1 or from the numbers list to list 2 if the number in list 1 is not already in list 2. So add a number, let's do this, loop over numbers. So let's do that. For some number in numbers, if some number is already, so add a number from list 1 to list 2, only if the number in list 1 is not already in list 2. So if some number is not already in the distinct numbers list, if it's not already in there, add it. So for clarity, imagine we have this right here. We have numbers, right? And let's just say numbers is this list. 1, 1, 3, 2, 3, 1. And we have another list, I'm just going to call it distinct numbers, DS. We're going to loop over this list right here. And we're going to check one at a time each of these numbers. So let me do it in black. Let's check the first one. Is this number not inside DS? Like, is it in DS? The answer is no. So it's not in DS. Therefore, let's add it to DS. So let me come erase this right bracket. Let's make it, move it over. So this one is not in DS. Therefore, let's add it to DS. This one, it is in DS, so don't add it. This 3 right here is not in DS, so let's add it. This 2 is not in DS, so let's add it. This 3 it is in DS, don't add it. In this one, it is in DS, don't add it. And so now the distinct numbers is 1, 3, 2. So this is the idea of what we're doing here. If some number is not already in distinct numbers, let's add it. So if some number not in distinct numbers, do what? Distinct numbers dot append some number. And that's it. That's the solution. So now after we're done, if I want to print out distinct numbers. Check this out. And I'm not even printing it nicely with a for loop. I'm just printing it. And here we go. Enter some numbers. I'll enter the same ones I showed the example of. 1, 1, 3, 2, 3, 2, 3, 1. There's your distinct numbers. 1, 3, 2. Perfect, right? So what's the problem actually say to do? It wants us to print it out. The distinct numbers are. I mean, so we can do that. No problem. Print the results. The distinct, no, wow. That was a comment. Print the distinct numbers are colon end equals, so we can stay on the same line. Now it wants us to print it in a pretty way. 1, 1, 3, 2, 3, 1. So here it's just printing the list. It wants us to remove the commas and just put spaces. So sure, you'd have to do this as a for loop now, no problem. So for num or val in, I'll put num. For num in distinct numbers, print num, I'll do this to formatted printing. Print num with a space afterwards, dot format num, and we need to stay on the same line, right? We're going to print one number, the number 1, followed by a space, stay on the same line so we can print the next number in distinct numbers. Let's run this, and we get 1, 1, 3, 2, 3, 1. And here we have our exact answer. The distinct numbers are, boom. Pause the video if need be, go back, watch that again. You want to code that yourself. You want to code it yourself. Make sure you understand it clearly. Here's a solution where I used an extra function, which is super cool. So here, the code that I did live, I didn't want to use that extra function because I wanted you to be able to see both of these. So what I did here, we read in the numbers, and then we looped over those numbers and we solved the problem. Right? We looped over the numbers, found the distinct numbers, and then printed it out. What did I do here is this portion of the code where I'm looping over the numbers and making that, and I have that new distinct numbers list, and if it's not in distinct numbers, I'm adding it, right? All of this code in this solution, I simply brought over to a function. So what I really did is I'm going to copy that code, I'm going to cut it, and here define get distinct numbers. And so what I did is I sent over to this function the numbers list for some number in numbers. If some number not in distinct numbers, we've appended it. Now we need to go ahead and bring this new list into the function. And when we're done with all of this code in the function, what I do is I simply return the new list, which is called distinct numbers. So return distinct numbers, and that gets returned. So first of all, we need to call this function. So in our main here, let's call the get distinct numbers function. We're going to call it. So how do we call it? We basically type the name of the function and we send over the numbers list, because within this function, we're going to be accessing numbers, right? So we need to loop over that. And I need to therefore send over this numbers list to that function. Now this function is returning the distinct numbers. So I need to save that somewhere, right? So since it's returning something, that means you normally would have an assignment and you're going to save what it's returning. What is it returning? It's returning a list. It's really returning an address of that list. So I'm going to return the new list, distinct numbers, and I need to save that into a variable. I could call it distinct numbers, which makes sense. The only reason I don't like to, because I don't want you to think it has to be the same name. So here we're returning distinct numbers and you're going to save that into distinct numbers. That's what I would like to do, but some people get confused. Understand, you could have called this Bob. Save it into Bob, and I would have to then say, for num in Bob, print num. For num in Bob, print it, and that would work. But it doesn't make sense to call it Bob. Let me just show you that this would work. 1, 1, 3, 2, 3, 1. The distinct numbers are, it works just fine. So I'm just calling it Bob so you understand it can have a different name than what we're returning. But in fact, it makes sense to call it distinct numbers because it is distinct numbers. So there we go. I run this code, and here we get 1, 1, 3, 2, 3, 1, and we are set. So the only difference between this solution and what I had previously, let me go back to that now, get rid of all of this, and we are close right here, is I didn't put that other part in the function. The determining which numbers are distinct and making that new list, I didn't do that in a function, which you didn't have to. It was a bit overkill of using functions, but it's good practice to be using functions. That's why I did it. All we're doing in this video is really practicing more problems to get more exposure, more comfort with lists. You need to be coding these. You're not coding these. That's the first failure, and it's a huge failure. Make sure you coded that last one. If not, even pause the video and just code up this. Even if you're looking and you already have the solution, there's still some value of actually coding it. Let's go to the next one. Write a short program to generate a list of 10 random numbers, each between 50 and 80. Sort that list, and then print that list. Let's make some comments. So it says, I already made a new program. It's called sort random numbers. So go ahead and do that. Pause the video. Sort random numbers. Write a short program to generate a list of 10 random numbers. So first I'll make a main. Come up here, define main. All right, so we need to generate a list of 10 random numbers, but each between 50 and 80. Sort that list. So if we want to generate 10 random numbers, that means we need to loop, right? Loop 10 times. That's easy. For I in range 10. That's super easy. What do we do within that loop at every iteration? Generate a new random number between 50 and 80. Done. Append that new number to a list. And that list will have to be an empty list. So up here, we need to make an empty list called random numbers. That's pretty easy to do. Random numbers equals empty list. Append that new number to random numbers. Done. So how do we generate a random number? We know how to do that, which means we need what at the top? We need to import random. And if you want to have the same sequence, let's go ahead and make a seed. So random dot seed. What seed do I want to put? Let's call Thani the name of the seed. So random dot seed is Thani. Let's make a new random number. So I'm just going to call this randnum equals, and what do we have? We're going to have random dot randint 50, 80. Done. Append that new number to the list random numbers. So here we have random numbers dot append randnum. So we're appending, which means we're adding it to the end of the list. That's all we're doing in that for loop. So now after the loop, let's print the list. Print the list of random numbers. Print random numbers, and let's see what we get. Let's run it. You should get the exact same 10 random numbers. I run it again and again and again. They're going to be the same numbers because we have the same seed. You understand that already. How do we sort this list? How do we sort it? It's actually super simple, but maybe we forgot. It was a couple videos ago. I think it was the last video. It's one of those list methods that are available to you. So sort the list, you simply take your list, random numbers, dot sort. Done. And now it's printed again. Print the list of sorted random numbers. And here we go. You can see the list is now sorted. Super easy, not much to talk about. Let me erase this. Let's print it without it being, let's not print the unsorted list. This is what the problem asked us to do. Short programs generate a list of 10 numbers. So you should think, ooh, I need to loop 10 times. Done. I need each time generate a random number. You should be able to do that. That's within our comfort zone. That's easy, which means, ooh, I need to import random. Done. Well, after I generate that random number and I save it into a variable, I need to sort that, right? So it did say generate a list. So you might be thinking, well, how do I add this number to a list? So then you think, I need to make a list. Let's make it empty. Give it a name. It's an empty list. And every new number you generate, we simply append it to, add it to the end of this previously empty list. We're appending this new number that we generated to random numbers, which is our list. And then we simply sort it and we print it and we are golden. Not that bad. Hope you coded it. Pause the video, make sure you code it, make sure you fully understand that. Let me zoom in some in case that wasn't large enough. What comes next is, here's a solution, pretty much similar to what I did without the comments. Let me come back to here. This is much better. Let's also do this through the power of pause. And here we go. Love pausing. All right, there's a solution that we just made better than the one that I had shown in the slides. Shifting a list. What if you want to shift all elements in your list one position to the left? How would you do that? So imagine we have this list of 10 elements and we want to shift each one position to the left, right? So if this was at index 9, we want to move it to 8. The one at 8, move it to 7. The one here at 0, 1, 2, 3. The one at 3, move it to 2. The one at 2, move it to 1. The one at 1, move it to index 0. But something's already at index 0. So we need to move that all the way to the back of the list. How would we actually make that happen? So let's come back over here to the tablet. Let's erase what we had here. And let's pretend we have this simple list. Let's make it just size 5. 7, that looks bad. 7, 2, 6, 8, 0. All right. So I said that we want to really do these moves. We want to do that, we want to do this, we want to do this, we want to do this, and then when we're done, we want the 7 to come all the way around and go into there. So how do we do that? Just think about it. So clearly we can't just start by taking what's here and moving it over. So let me put the indices. Let me write in the indices. This is index 0, index 1, 2, 3, and index 4. So clearly I can't just take what is here, this 2, and move it here, right? Because then I'll be deleting the 7, right? I'll be overwriting the 7. So how do you do that? What do you do? Well, one idea is let's first take this 7 and let's move it over into a temporary variable. Literally, I'm going to call it temp. So here's a temporary variable. I'm going to call it temp. I'm going to grab this 7. I'm just going to move it over here into temp. So now that I've done that, guess what? I can move the 2. And it doesn't want me to. I'll move the 2 and the 6 together because that's what would have happened. Basically, I want to move the 2 from index 1 to 0 and then move the 6 from index 2 to index 1. No problem. It worked in one. Then I want to move the 3 to index 3 to index 2. So the 8's moving over. Then finally, I want to move what's at index 4 to index 3. And then when I'm done, 4 is now available, and I'm going to move that 7 back over into index 4. That's really what happens. And so when you look at the code, it follows that clearly. So here's the actual solution to this. We want to make those moves the way I just described. Here's the solution. So imagine we have this list of elements. we first take, and a function called shift, we take the value at index 0 and we move it temporarily into a variable called temp. We're then going to loop from index 1 all the way to the length of the list. So let's look at what that means. So here, loop from index 1, that's the starting point, all the way through the length. Well, how long is this list? It's size 5. So you're going to go from index 1 all the way to index 5, which is right here, which is out of bounds. But remember, on a range function, we go one past where we want to be. So on this for loop, we're really going to only be looking at those indices, which is perfect. And we're going to move each one of those one position to the left. So we take the value at index 1, we save it to index 0. Then we go to the value at index 2, save it to the value at index 1, then the value at 3 to index 2. Then finally, we take the value at index 4, put it to index 3. And when we're done with that loop, we save that value that's over in temp into the last index of the list, which this might be convoluted. This says we'll save temp into the length of list minus 1. And that works, right? You can absolutely do this. You could say, we could say list of the length. Oops, let me get rid of that last thing. The length of the list minus 1 equals temp. You can absolutely do that, okay? Or, because, and think of why you can do that though, because what is the length of the list? It's 5. 5 minus 1 is going to be 4, and that is the last value that we're looking for. But because that's how you would do this in most languages, but Python gives negative indexing, right? So we can really just say list of minus 1 equals temp, which is so much easier to do in Python with that negative indexing. Negative indexing is super cool, super helpful, not available in many languages. Python gives that to you. Here's an example of how Python can simplify your code. What if you wanted to get the English name for a particular month number? So month 1, January, month 11, November, month 12, December, so on. You ask the user, enter a month number. They enter 3, and you want to print March. They enter 7, you want to print July. They enter 12, you want to print December. You would have this very long, nasty if-else statement to make that happen, right? That's hideous. What if you could do something else with lists? Look how using lists can now simplify your code and your life. If we make a list of strings of size 13, index 0 will be empty, but index 1 will be January, index 2 February, index 11 November, index 12 December, and now check out the code. If we make this list of strings where I made this index 0 an empty string, and the reason why could be because I wanted something at index 0, so January could be index 1, February index 2, and so on. I just simply ask the user for a month number, and then I print the month is months at the index that they entered. Super easy, super cool, much better than this disaster of a solution that we see right here with that long, convoluted if-else statement. What follows in these slides, I'm going to go slowly. I'm not going to explain this because this is something I don't want to waste your time. I'm at 28 minutes. This is something that you need to look at, try to do on your own, try to understand, and when there's confusion, reach out, leave a comment, ask questions, message me, and we can help. So here's a lot of check yourself questions. The question is, what is the list after applying each of the following statements? And each line of code is independent. So each of those statements, pause the video and try to ask yourself, what would the list be after each of those statements? And I'm not going to go through this with an explanation. I'm just going to show you the answers. And if we're ever confused in any way, reach out, ask me why this made sense and why we got that particular answer. Here's another one. What is the return value for each of these statements? Here's the statements. And then here are the solutions. Reach out, ask questions if there's anything there. These are great questions that can be asked on quizzes, on exams, So you don't want to look at the solutions. You want to try each one of these on your own before moving on in the video. I just don't want to give you an hour-long video and make you have to watch this when you can go try those on your own. Given these two lists, what is the result of each of these statements? Here's those statements. What is the result of those statements? And we see here are those results. Again, hopefully you're okay there. What is the result of each of these statements? Here we have list comprehension. Given that list, use list comprehension. These are fun. For x in list 1, if x is greater than 1, here we're going to have a list of only two elements, the 30 and the 2. For x in range, is 0, 10, 2. So this is going to be 0, 2, 4, 6, 8. Love it. So much fun. Or from 10 down to 0, but not including 0 by 2s, 10, 8, 6, 4, 2. Pretty easy. But make sure you understand that. Given these two lists, what are all of these values and what do they evaluate to? Again, you're going to want to go through this and then compare it to your solutions. Solve them on your own. Don't look at the solutions until afterwards. What are list 1 and list 2 after each of the following lines of code? List 1 is this, list 2 is that. Let's understand why. Going through this quickly. What we have here is simply we want to write statements for each of the following. Okay, create a list with 100 Boolean false values, assign the value of 5.5 to the last element of the list, and so on, one by one. Create a list of 100 Boolean false values. That should be something easy to do. We should be able to do it like this. List equals some list, call it LST, don't call it LIST, because that's a built-in function. So call it just LST, call it Bob, call it whatever you want, equals false times 100. That's it. Assign the value 5.5 to the last element in the list. We could have done that, but it's better to use negative indexing. In Python, may as well take advantage of Python to use negative indexing. Display the sum of the first two elements of a list. That's it. 0th element plus the first element. Compute the sum of the first 5 elements in a list. It's that simple. Look how cool that is. If I said compute the sum of the first 5 elements in a list, most would have done something like this. File new. Most would have said, okay, well, if I have some list called LST, right? I want to get the first 5 statements. I'll say sum equals LST at index 0 plus LST at index 1 plus LST at index 2, and so on. We only have 2 more to go, but what if it was the sum of the first 200 values on the list? You don't want to be doing this solution, like plus LST at index 198 plus finally LST at index 199. What a disaster. What a fail that would be. Instead, you just say sum equals, and what do we have here? You're just going to, let me use total, not sum. Notice the color here because that is a function. So let's call this total. You don't want to use a variable name that really belongs to a function. So total equals the sum of, and let's actually use list slicing. So we say LST from index 0. If I wanted the first, what do we say here? 5 elements, or let's say 10 elements. It would be from 0 to 10, which is 0 to 9, which is the first 10 elements. And that will give us the sum of those elements. Super cool. Find the minimum element, we're going to use the min function. Find the maximum element, you can use max function. Generate an index and display the element of this index, just like this. Again, pause the video, chew on that, make sure you're okay before moving on. The last problem of lists and the last problem of this entire video series in OOP, let's get right at it. You want to buy lotto tickets, and each ticket has 10 lotto numbers, where these numbers are not of your choosing. Instead, the system's going to generate these numbers for you, and they're generated from the integers 1 through 99. So a given lotto ticket has 10 numbers. Those numbers are maybe, I'll give an example ticket, maybe 12, 18, 94, 73, 62, 8, 15, 71, 65, and 49. Those would be the 10 numbers on one ticket, for example. This problem, kind of weird, but it's all about practicing lists. This problem says we're going to be reading in many lotto tickets from the user, where one ticket, again, has 10 numbers. We're going to read many lotto tickets from the user, not just 3, 4, maybe 20, 30, 100 tickets, where one lotto ticket of all 10 numbers for that ticket will be entered on one line. Then the user will hit enter, and they're going to enter many lotto tickets, and we're going to scan all of the 10 numbers for each of those tickets that they enter. What's the purpose of the problem? We would like to know if, amongst all of those tickets we read, have we fully covered all of the integers from 1 to 99, or are all of the integers from 1 to 99 found within the lotto ticket numbers that we scanned in from the user? Does that make sense without any additional explanation? Let's look at an example of some of these tickets we would read in. So here I have, what is this? 61 lines of text, where the last line has just a 0. So it's really 60 lines where each line represents a lotto ticket. Here's the first lotto ticket with 10 numbers. Here is the 13th lotto ticket with 10 numbers. Here is the 60th lotto ticket with 10 numbers. So the user is going to enter in all of these lotto numbers, and we're going to read those numbers. We're going to read those lotto tickets, one ticket per line. We've seen how to do that. We're going to read this entire line. We're going to split it on spaces. We're going to immediately convert it to a list of, not strings, but a list of integers using list comprehension. And then we're going to have to solve the problem. The last line of input will have a single 0. If you have a line of input with a 0, we break out of this loop that we're in, because we're in a loop scanning from the user. Once we break out of the loop, again, what's the problem? Here we have 60 lines of text. Each line has 10 integers. Those integers are from the numbers 1 to 99. So if we have 60 lines times 10 integers, we have here 600 integers. The question is, among all of these 600 integers, there's clearly a lot of duplicates. Here, if I click on 48, look how many 48s we have, right? If I click on 95, we have several 95s. If I click on a 21, we have several 21s. The question is, among all of these 600 integers, can we find every integer from 1 to 99? Or another way of wording this, from the integers 1 to 99, are all of those integers, can they be found within these 600 ticket numbers? That's the question. So, and I'll tell you, if you remove this last line, in fact, the answer is no, because this was just auto-generated text I made here to generate these 600 numbers. And here I have 590 numbers. And among these 590 numbers, I can tell you the answer is no. Which of these numbers was missing? I have no idea. I can click. We have duplicates 33, duplicates of 38, 44, 81. 1, I see a duplicate. 26. Aha. 26 was the one number that was missing. We have 11s. We have 63. We have 2 13s. We have plenty of 14s. But this number 26 was missing and not entered until this last line. So that's the problem. Given a series of these lotto numbers, we want to determine, are all of the integers from 1 to 99 found within those lotto numbers that you're reading in from the user? So that's the problem. What is the approach? How do we go about solving this? We're going to read the tickets, 1 per line. We know about the 0. That's when we stop reading. That's when we're going to break out of that loop. How do we solve it? There's many different approaches. I'm going to cover 3 of them. The first is going to be using a Boolean list that will store whether or not we've seen one of those integers from 1 to 99. Another is going to be adding newly seen elements to a list. If we have never seen them before, we're going to add them to a list. Another is going to make a list of all numbers from 1 to 99 and then remove from that list each number that we have seen. And I'm going to go through each of these solutions. So as to this first solution right here, let's come over here to the tablet. And Here, I said that we're going to use a Boolean list to store whether or not we have seen a number. So imagine that we make a Boolean list, and it's going to be a huge list. How huge is this list going to be? It's going to be of size 100. So I'm going to make a new list. Let's call it seen. You know, let me actually, can I click this and bring it down? No, let me just hit back. Let me just erase all of that. I'm going to make a new list called seen. Seen is going to equal this. I'm going to take false, and I'm going to duplicate that 100 times. So the result is I have this list here. I have seen, which stores a reference to this list, and here's my list. It's a huge list of size 100. So index 0, 1, 2, 3, 4, 5, 6, 7, 8, dot, 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 dot. And this is 98, and this is 99. All right, so what's going to happen on this problem is all of these are going to be initialized to false, 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 right? That's how it works. Everything's initialized to false. So I make this list called seen to show whether or not we've seen a given number, because the goal is to see all numbers from 1 to 99. That's the goal. So we really want to make all of these indices true. So now imagine we read in a number from the user, and that number that we read in from the user is the lotto number or lotto ticket. Imagine we read this ticket from the user. 12, 27, 3, 19, 89, 2, that's 1, 2, 3, 4, 5, 6 numbers, 61, 68, 73, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's pretend we'll make a new starting number. Let's say we read the number 5. All right, so what happens when I read this entire line from the user, what I'm going to do is I'm going to loop over each number in that line. I'm going to loop over each number in that line, and when I come to the 5, right here, let me put this in red. When I come to the 5, I'm going to actually come right here, and I'm going to make index 5 true. And then I come to the 12, and I would make index 12 true, which is somewhere in here. Then I come to the 3. Let's make index 3 true. So I'm going to erase the false, and index 3 is going to become true. I come to the 19, I do the same. Then I go to the 89, I do the same. I come to the index 2, and I'm going to make index 2 as true. Make this true here. And I do the same for index 61, 68, and 73. The result is after reading this entire ticket right here, when we read this entire ticket at the bottom, this lotto ticket, we will have set 10 unique numbers to true within this seen list. And so we're simply going to repeat that process for every single lotto ticket that we read in. When we're done reading in all of the lotto tickets, what we simply want to do is we want to look at this portion of the seen list from index 1 to 99. I don't need to look at index 0 because index 0 was not an allowed lotto number. And I hope y'all can see why I made this list of size 100. I could, because we're only looking at the numbers 1 to 99, right? So I could have simply made a list of size 99, but then if the user enters a 3, for example, I would have had to have set index 2 to true because it was a 0-based list. But by making this index 0 right here, and by setting it false and we're not even going to touch it, we made the list 1 bigger than what we needed, which is perfect. So for the numbers 1 to 99, I'm literally going to store them at indices 1 to 99, and we're just not even going to use this index 0. So what I want to do is when I'm all done is, I just want to loop over this section of the list that you see right here. this section of the list, and I want to check, is everything true? If everything is true, then we are golden and we have exactly what we're looking for. So in fact, let me pull up the code so we can just go right to it. This is the solution, and let me now go through this. I call your main on line 41, and then up here in line 1, I have my main function. I first say, let's make this, I called it covered here. I could have called it seen, but I called it covered. So are all of those numbers covered? And I have, again, false times 100. So I have this list of all falses. I have a while true loop scanning the input from the user as an input line. If the line is 0, break. If it's not 0, then we're going to do what? We're going to take that entire input line, we're going to split it, and we're going to use list comprehension to get this to a list of integers. And then we're going to loop over that list of integers, and we're going to set this list called covered to index I to be equal to true, okay, which is what I just depicted for you on that tablet. So for I n numbers, meaning, coming back to here, this 5 is that first value in numbers. We're going to set index 5 to true, then index 12 to true, then index 27 to true, and so on. So this 19 here, while this is a lotto number, I'm going to go to that 19th index right here, and I'm going to set it to true. I hope that is clear on what we're doing with this approach. And so now, when I come back here to the code, after we do these two lines, 19 and 20, we come here to line 23, and I make this all covered variable saying, hey, has everything been covered? All those numbers from 1 to 99? Let's assume the answer is true. They've all been covered. So I set it to true. Then I say, let's loop over those indices of this covered array, 1 to 99, of this covered list from 1 to 99. And if anything is not true, we need to change all covered to false because it's not actually all covered. So I said, let's assume everything's covered. And if we see anything that's not true, we'll set all covered to false and we'll just break out because no need to keep on looking. So finally, if all covered is true, which would mean all of those indices from 1 to 99 are still true, then all covered is true. Then we can say all of the digits between 1 and 99 have been included in those lotto tickets. Otherwise, we would print, bummer, not all of the digits are covered. That's an interesting solution using this auxiliary list of Boolean values that we just simply set to true, and then we loop over all 99 of them afterwards to make sure they're all true. And if they're all true, great, we print this one. If they're not all true, we print this. That's the first solution. What's a second solution? Adding newly seen elements to a new list. So every time we see a unique number that has not been seen before, just add it to the new list. And then at the end, if the size of this new list is 99, we have covered all of our numbers. So check this out. Here's a second solution. I called this list ticket numbers covered, and it's empty. All of this is the same. We're going to read in the line, make sure it's not 0, because then we'd break, use list comprehension, convert that to a list of integers. And now I'm going to loop over every single lotto ticket. And I say, if the given number of that lotto ticket is not in tickets numbers covered, because again, ticket numbers covered is an empty list currently, and now we're looping over that first lotto ticket. And I'm effectively going to say, let me come over here. We're not going to have this seen array anymore, so I can get rid of this seen. I keep saying array. It's similar to a list, but they're similar, but pretend I said list there. Here we have this lotto ticket we're reading in, and we have this, it's called ticket numbers covered list. Ticket numbers covered list, which is initially empty. It's empty. And so what I'm going to do is I'm going to come to this 5. I'm going to say, are you inside the ticket numbers covered? Nope. Cool. Let's add you. 12. Are you inside the ticket numbers covered? Nope. Let's add you. What about you? 27. Nope. In fact, this first set of ticket numbers, they're all going to get added, right? They're all going to end up getting added in here. But now imagine we have a new lotto number on the second line. And this lotto number is 18, 68, 12, 24, and so on. Well, when I read 18, I say, 18, are you in this list? Nope, let's add 18 up here. Then I say 68, are you in the list already? And the answer is yes, 68's already in there, so we won't add 68. 12, are you on the list? Nope, let's add 12. 20, oh, 12 was in the list. Sorry, 12 was in the list, so we won't add 12. 12 is already here at index 1 of this list, right? So we don't need to add 12. So this is the idea of this one. 24, are you in the list? Nope, let's add 24, and so on. So we're only going to add elements that are not currently in this ticket numbers covered list. So if I is not in the ticket numbers covered, then we're going to simply add it. We're going to append it. It's that simple. And then once we're done with that, what's going to happen is the following. And remember, we would have broken out of the while loop, so we make it down to here. And I simply say, if the length of ticket numbers covered is 99, then we have covered all of those digits. Else, bummer, we have not covered them, and I could print the ones we've covered just to see. So I didn't even run the code the first time, so let me run it. Here I'm going to come back to Notepad. Let me run this. Was this all? Yeah, that's all of them. So if I run this code, hit run, and I paste all of that input, I just pasted in one go, and it says all of the digits between 1 and 99 have been covered. Whereas, if I were to delete this last line, remember that 26 was the only number that it was waiting on. If I delete that last line, and then I run this, what's going to happen is it says bummer, not all of the digits were covered. Same thing here. I could run this, and it's going to say bummer, not all of them were covered, and then it prints the ones that were covered, but you can't really see because it's kind of hard. It's not in sorted order. I could have actually just sorted it really quickly. That would make sense. Let me type this, ticket numbers covered dot sort. And so now let's print it with that same input. Run this now. And we can see that we are missing the number 26. Right here is what's missing, which is why this one was not covered. Of course, if I put this full line, this back in, so now we have all of those lotto numbers in here, you will see that this is, in fact, full coverage of those numbers. So this was a second way of solving that same problem. And now we come to the third way, which is making a new list of numbers between 1 and 99, and then removing from that list each number that we've seen from the lotto tickets. Pretty similar idea, but instead of starting with this empty list that we're going to add stuff to, and then when we're done, we want to see if it has a size of 99, meaning we've added every possible one of those 99 integers. Instead of starting empty, appending, and hoping to get to size 99, we do the opposite. We're going to start at size 99. I say numbers not covered, and I put every number from 1 to 99 inside that new list. This is using list comprehension. We've seen this already. So I've made a new list of all numbers between 1 and 99, and I call this numbers not covered. And then what do? I loop over every single number within a lotto ticket. And I say, if that number in a lotto ticket is in numbers not covered, I need to remove it. That's the goal. I need to actually remove that. So if I come back here to the tablet, so now let me make this numbers not covered. We had it, numbers not covered list, which includes all numbers, all integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, ... 97, 98, 99. Okay, this is this list. So now what happens is as the user is reading in these lotto numbers, right? So if I come to the 5, what I'm going to do is I'm going to remove this 5 from the list. I come to this 1, I'm going to remove the 1 from the list. If this were a 3, I don't remember what it was, but I'll remove the 3 from the list. Remove the 19, remove the 89, remove the 2 from the list, remove the 61, remove the 8 from the list, right? Remove this 2, it's already removed. So this is the idea. Remove the numbers, imagine this was a 99, remove the 99 from the list. So when we're done, and we're done looping over all of the input lotto numbers, right? And we break out right here, we break out of the loop. What happens is we'll know if we've covered all 99 of those integers if the number's not covered, if the length of it is 0, meaning we've removed all possible 99 integers from that list. It now has a length of 0. We have covered all of those integers, and here is a solution. So what's cool about this is we see 3 different ways of solving the same problem using lists. I hope first of all, I hope you coded those up. If you didn't, go back, pause the video, code each one of those up. If you can code those, even just looking at it, you code it, you understand the solution, and you practice a few problems with lists, you should be good. And let me share the great news with you. We are done. That was the last slide. Get excited. I have to put a couple of GIFs in here. I love the Fresh Prince GIF. Not sure about that one, but feel the one that you enjoy. Gotta have Thor. Let's go. It has been fun. As always, reach out, ask questions, leave a comment. Take care, everyone.